Hey everyone, welcome to SingularityComputers Client Build 8, Part 6. The name of this build is Cytotoxic. In the last video, I completed both of the loops. In this video, I'm going to focus mainly on completing the wiring and filling the loops. I'm now going to get started with the wiring. So I've covered these cables previously. They're all sleeved in $1 Million PC black shrinkless sleeving, and most of them have been made from the ground up. All of the lengths have been customized. Some of the configs have been changed, new connectors. Anyway, now it's time to get them installed. I'm now about halfway through installing the cables, and I'm going to install temperature sensors into both of these loops. I'm going to use Bits Power plug temp sensors, and I'm going to install them into the backs of the pump tops. It's a perfect spot for them because you need to be careful when using plug temp sensors. They can partially block the flow of your loop because of their depth. So sometimes I use extension fittings to set them back outside of the flow of the loop, or you can just find a part of the loop where they're not going to infringe on the flow, such as an unused inlet or outlet in a pump top. I've sleeved the wiring for these, and it's now time to get them installed. I've now installed all of the cables that we've sleeved so far, but there's still a lot of work to be done on the wiring because I still need to do custom wiring for the fans, the pumps and the lighting. I also still need to do the cable management because currently these cables are just sitting here. I haven't yet cleaned them up or set them into position. Now, I had the 24-pin and PCIe cables installed previously in the build log. I've now also installed the 8-pin EPS and 4-pin ATX, which you can barely see up here through this gap, and also the SATA power around the back of the build. So I've only just started the cable management back here. You can see that I've done the SATA power cables, and what I'm using here is some components from ModSmart. I'm going to put a link to these in the video description. This is a clip designed for 4 cables. These are also designed for 4 cables, but they have sticky pads on the back of them. And these are really handy when doing custom wiring and sleeving. They're a real clean way of doing your cable management. I've also used them for the 8-pin EPS and 4-pin ATX. You can see I've gone from a bundle where I've used a cable tie out to a number of these components, and I spread all of the wiring out like this to improve aesthetics, to clean things up, but mainly because in a bundle there is no way these cables would fit between the motherboard and the motherboard tray. Now, in the stock TJ11, these cables are actually routed behind the motherboard tray, but I've redesigned a lot of this case with my case mods, and one of the things that this has affected is the cable routing. Because of the horizontal blanking plate that I installed, and this blanking plate was absolutely critical. It was to improve aesthetics, but also once I removed the ducts, the verticals that you can see at the back here were hanging in midair, so the motherboard tray was just moving freely. This blanking plate solved that problem, but because of it I needed to reroute the 8-pin and the 4-pin, and in the TJ11 there's a large gap behind the motherboard. You can see the large standoffs, so it worked out well. They fit behind the motherboard nicely. Most of you will also know that I installed a vertical blanking plate to hide wiring. And now you're really going to see that blanking plate come into play. All I need to do, well, all I'm going to do to this front panel wiring is replace the stock heat shrink with some MDPC just to clean things up a little bit, because only 10mm of the end of that wiring is going to be visible. And it also hides the SATA data, SATA power, and anything else I decide to route back there, possibly some wiring for the lighting also. In the bottom compartment, you can see that I've started to clean up the wiring coming out of the power supply, but there's still a lot of work to be done. This wiring is for the fans and the pumps, and it all needs to be shortened and managed. And coming up, I'm going to show you what I'm going to use to power all of these components. I'm now going to move on to the installation of the lighting. Previously in the build log, I've mentioned that I'm going to go for the Serenkov radiation effect in this build. It's basically just a blue glow. The blue glow is seen underwater in a nuclear reactor, and it's caused by the radiation passing through the water. I think the best way to create this effect is with UV lighting and UV reactive coolant, because it does appear to be a UV reactive type effect. It's a soft glow, and it emits from not just one surface. It kind of emits from the fluid itself from everywhere. So I'm going to use UV lighting throughout the rest of the build, except in the front panel where I've used the NMX TV Appleish blue LED fans, because you don't want to mix UV light with normal light. It's just going to take from the UV effect. And it's difficult enough to create a good UV effect to begin with, because most UV lights don't put out the correct light, and a lot of UV reactive components aren't UV reactive enough. So it's not often that I see a good bright UV reactive effect. But you just need to get your hands on some good UV lights. So I have here some Lantron Flex lights, the 30 LED version, some Logisys sunlight sticks, the 12-inch version, and some Logisys LED corner lights. These are about 40 centimeters long. They're all UV, they're all powered by 4-pin Molex. The Lantron Flex lights have a number of benefits over a normal LED strip. They're higher quality, longer lasting. They're waterproof, they're very flexible, they put out a lot more light. They also put out light almost 360 degrees. They can be cut down to length, and they create a very good UV effect. The Logisys sunlight sticks are very bright. They put out a massive amount of light. I know that's not important for a good UV effect, but they do put out, close to the correct light. They create a good UV effect. You can see that they're LEDs, but configured like a cold cathode. Now, I really like these Logisys LED corner lights because they can be hidden easily in a build. And they're frosted, so it creates a nice soft glow. And again, they create an excellent UV effect. Okay, to power the fans, the pumps, and the lighting, I'm going to use a Bits Power X station. I've been using these for a long time in my builds, and they're great. If you want to keep everything clean and hidden away, it means you don't have to use external components such as fan controllers, and you can see the massive amount of outputs. It allows you to plug everything into one spot, and it's all powered by a single Molex, so it means a whole lot less cables. There's a number of different versions of these. There's different colors. This is the blue version. It has blue LEDs. There's also a larger version which is double the size with double the outputs, and you can do a lot with these. I've hooked them up to vandal switches in the past for lighting, so that you can plug a whole lot of lighting into them and switch it all on and off at the same time. You can do that to pumps and fans and anything else. But anyway, I'm going to come back to the wiring. I'm now going to go back to the mods. Now, as I've mentioned, I'm going to reinforce the water cooling loops, and I've just been through and done my measurements, and I've decided to reinforce them in 3 places. 2 for the graphics loop and 1 for the CPU and motherboard loop. The loops don't really need to be reinforced. They have a slight amount of movement, but despite that, they are plenty strong enough. The only reason I'm doing this is to add another feature to the build. The material I'm going to use is 10mm smoked acrylic, the same material I used for the front panel mod. And because these are not going to have to take much weight, I've decided to go for organic shapes. So I'm going to carve as much material out of them as I can. They're going to be very lightweight and small with a lot of curves. And I'm also going to polish them up so they're going to be very transparent and shiny. The design I've decided to go for is to clamp the loops between the acrylic blocks. And I'm going to clamp the loops where there's fittings, not where there's acrylic tube, so that it's a lot stronger. And I want to clamp the loops so that there is absolutely no movement, so that the loops are reinforced from all directions. And what I need to do to clamp the loops is bolt right through the acrylic blocks. So as you can see, I'm tapping some threads, M4 threads, and I'm now bolting them together to test the threads and also to start shaping them. I'm going to take you through the process of shaping and polishing them in the next part of the build log. I'm now going to skip to the end of the process because at this point I've just about finished the smallest reinforcement. Now this is what I used to polish them. This is a product from Novus. It has a heavy scratch remover, a fine scratch remover, and a polish. And I use this often for removing scratches and marks from side panel windows, reservoirs, acrylic tube, basically just any plastics and acrylic. And I took this back to about 500 grit, so it was still a lot of sanding. I think I sanded it for over an hour and a half. And I then used the heavy scratch remover and a felt polishing attachment on a Dremel to polish it up. And I then moved on to the fine scratch remover with a rag and then the polish. Now I'm still going to go over this again with the felt polishing attachment on the Dremel because you can still see some fine lines. And the other piece I still need to sand a fair bit. You can still see some marks in it. So coming back to the wiring, as I mentioned, the next step down here is to customize all of this wiring and connect it to the Bits Power X Station. So as you can see, I've installed the X Station and I've also installed a couple of splitter PCBs because the Bits Power X Station has 4 12-volt 3-pin fan headers. The rest are 7-volt and 5-volt, which is great for certain applications, but I need to connect 10 radiator fans and I want to run them all at 12-volt because they're low RPM fans, they're silent enough. So I need to either split the fan headers or run the fans from Molex. And I can certainly use splitter cables, but I don't like using them because they make a mess of wiring. What's a whole lot cleaner is splitter PCBs. So I'm using two Phobia Molex to 6 3-pin fan splitter PCBs. I'm now going through and customizing all of the wiring in the bottom compartment. So I'm now shortening the fan cables, and basically the process is find the length, cut the cable off to length, cut the sleeving back a little bit, strip the ends of the wires, crimp new pins on, put some heat shrink over the cable, put the connector on, and then heat the heat shrink. Just to give you an idea, it took me a bit over 3 hours to customize all of the wiring in the bottom compartment. At this point, I've also connected and managed the front panel wiring, and now you can really see the purpose of this vertical blanking plate. Looking from the front, you can see that only a very small part of the front panel wiring is visible, and actually I'm glad I didn't make the gap between the blanking plate and the motherboard any smaller, because I was only just able to bend this wiring up and around to plug it into the motherboard. At this point I've completed almost all of the wiring, so you can see how things have turned out in the bottom compartment. I'm going to complete the wiring in the next part of the build log, and I'll give you a much better look once it's complete. I'm now going to move on to the filling of the first water cooling loop. Okay, I have the CPU and motherboard loop set up and ready to go. With multiple loops, it's important to fill one loop at a time. One loop is difficult enough to manage. So I have the usual precautions in place, paper towels covering every join wherever there could be a leak. These are not much of a defense against leaks. I only use them as an early warning sign to show me if there's a leak. What you also really need to do is have your drainage system hooked up and ready to go, so that if there is a leak, the coolant that's already in the loop doesn't drain through the leak. You need to use the drainage system to get the loop empty as quick as possible, and also you need to power your pumps externally. Now you can use the power supply in your build and jump start it, but obviously if there's a catastrophic leak you can still end up damaging your power supply. What I recommend is an external dedicated power supply. I use one from Phobia, which I've modded a switch into. I'll put a link to it in the video description. I also found one recently which already has a switch on the 12-volt side. So, you know, the switch is close and easily accessible, and it also has a SATA connector, so, you know, it's handy for powering hard drives externally. So I'll put a link to both of those in the video description. So just a quick look at how I'm externally powering the pumps. This is the modded Phobia external power supply. To this I've connected a Bitfinex Alchemy Molex splitter cable for powering multiple components. For this build I had to make a female Molex to female Molex adapter cable, and that's because I had to change the connectors on the pumps from female Molex to male Molex so that I could plug them into the Bits Power X Station. Okay, so the coolant I've decided on for this loop is Mayhem's X1 UV Blue to fit the theme and to give the Serenkov radiation effect. I'm now going to talk about single and multiple loops. The only reason I went for dual loops in this build was for aesthetics and to fit the theme. I wanted a lot of water cooling components in this build. That's why I used so many fittings I wanted two reservoirs and loops with contrasting colors. The only reason to go for dual loops for performance is if you have so many water blocks in your loop that by the time the fluid gets to the other end, it has heated up enough to substantially affect performance. That is one reason. The other reason leads to the same result. If your pump is not powerful enough to push the fluid through all of the water cooling components that you have, it means that the pressure drops, the fluid decreases in velocity, and the fluid spends more time at the water blocks, which means more heat transfer takes place, the fluid heats up more, and this means that the effect I just mentioned happens far more. So by the time the fluid gets through the water blocks, it is far hotter. And this is a misconception that a lot of people have, and it's something that I've talked about previously. Basically, the coolant should travel so fast through the loop that it doesn't heat up at each water block. It does very, very slightly, but it heats up as a whole. And you know, it heats up after many revolutions of the loop, and at the same time it's cooling down when it's going through the radiators. So basically the fluid should be a similar temperature throughout the loop, and if it's not, it means you need to either improve your pump configuration or split your loops. And obviously the best way to know that is by having two temperature sensors in your loop, one before the water blocks and one after the water blocks. But most pumps are, you know, very powerful. They can handle certainly the average water cooling system, which is a 360mm radiator, a CPU and graphics card water block with a massive amount of headroom. Now I can't give you any exact numbers. The best thing to do is have two temperature sensors, as I said, but basically right up, the first thing I would be doing is improve your pump configuration. So get a more powerful pump or go for dual pumps. After that, I would consider splitting the loops. There are negatives that come from splitting your loops. You're better off having one powerful loop for a number of reasons. One of them being redundancy. If you have two pumps in one loop, one pump fails, you have another pump to back you up. The other thing is sometimes you end up with an odd number of radiators and you want to run dual loops. So say you have three 480mm radiators, it means that you're going to end up with one loop half as powerful as the other, and it's difficult to split the radiators up between the water blocks. So in most situations, even for the most extreme builds, I prefer a single powerful loop over dual loops. If you want to run multiple loops for aesthetics, then that's up to you, and obviously I can perfectly understand that. That is also something that I will do. Anyway, I hope that answers people's questions, because I get a lot of questions about multiple loops and also about serial and parallel configurations, and that's something I'm going to talk about while I'm filling the second loop in this build. So as you can see, the loop is now full and circulating, so it's now time for the 8-hour leak test that I give all of my client builds. And the loop filled very quickly. It took less than 5 minutes. It went very smoothly. There was no leaks or problems of any kind. And I'm really happy with this coolant color. It's definitely on the light side, but it looks very much like the photos I've seen of Serenkov radiation, so it fits nicely. I still might end up darkening the color a little bit though, to better contrast with the other coolant color that I'm going to use. Anyway, that sums up this part of the build log. In the next part of the build log, I'm going to fill the other loop, finish installing the lighting, finish the wiring, and also finish the reinforcing for the loops. After that, the build is almost complete. All I need to do then is mod the side panels. Then I can go through all of the performance and temperature results. And I'm also going to show how I pack this system ready for shipping. That sums up this video. Thanks for watching. Please subscribe, like, and favorite if you want to see more.